Hello, everyone. Welcome back to SAT Math Question of the Day at Gmail. No, sorry. Welcome, everyone, to SAT Math Question of the Day, where we go over SAT Math questions with Professor Emeritus Seth Chaiken, University of Albany, and Joel, Seth's brother. And we're here to hopefully show you how to approach SAT questions and maybe even a lot of other math questions. Okay, this is from a practice test from many, many years ago, but it feels like it still could be put on the post-2016 test. So let's us do it. This is a free response, so we actually have to write an answer, and let us assume that it is a calculator. Although 20 years ago, this may not have been a calculator question. The new SAT, which will be given soon to everyone, will be calculator only. Every question will have a calculator.
Yeah.
Okay, here we go. Okay, please do it. Please read it. Come back and we'll do it now. Okay, pound of grass covers an area of 500 square feet and costs $3.25 per 500 square feet. What is the cost in dollars of seed needed to cover a rectangular area that measures 200 by 300? So this is essentially a ratio problem where it's really 325 divided by 500 times 200 times 300. This is a really good example of where it is a really good idea not to do the numbers, to put everything in as factors first, because now you could cross stuff out to make life easy. And then you just start crossing factors.
I wrote, do you see my solution written in black?
Absolutely, and my solution's in blue, except yours is neater. Yeah. So
I think of it as a word problem from 5th grade.
Yeah.
How many 500s go into 200 times 300 and then multiply that by $3.25?
Right. Seth hates when I say most people would do it this way, but probably many people will do it this way. You have to know something, that the area of a rectangle is base times height, but probably you know that the area of a rectangle is base times height. In this case, it's 200 times 300, and that you have to multiply that area, which is in square feet, by this ratio of 325 per 500. So the units here, Seth and I did not put the units in it.
They're all feet or square feet.
Yeah.
Well, we did look at, hey, did they change the units?
That's an important consideration.
And is the rate, the dollars per unit was given in units of 500 square foot.
Right.
They also I gave you a distraction that the grass seed is sold in units of pounds.
I didn't even notice that.
Yeah, so I said, okay, does pounds have anything to do with this? And then I read the rest of the question and having put in my mind, hey, look for pounds.
Yeah.
I read the rest of the question, and at the end of the question, I was, okay, no pounds. Don't worry about pounds.
Wow, that's pretty good. I didn't even notice the word pound in there for some reason. And trust me, I didn't do this problem ahead of time. I try never to do the problems ahead of time. Wow, it's interesting how the brain works. I didn't even notice that. But still, so far, Seth and I have not done something that's really important, which is to really put the units into this thing, so that because this problem you don't really need the units because it's so straightforward. But it's always a good idea to put the units in, particularly maybe when you're not rushing, so that you see that the units cross out. So it's $3.25 per 500 square feet. Feet squared. Okay? Times, now, you see the feet squared is in the denominator here. we really, if we multiply by a numerator that's in feet squared, the feet squareds cancel, and we are just left with dollars, which is exactly what we want. So that means we need an area. We know area is base times height. So it's 200 times 300, and now we put the feet squared in, right? And now the feet squareds cancel out, and we get the numbers that we need to multiply. So when you're stuck in a problem and you're not sure what to do, the units can lead you through the problem just by matching up the units and having the units cross out, which is weird to have units cross out. Usually we cross out numbers on fractions. But if you have the units cross out, that will help you tremendously and virtually guarantee that you get the question right, at least getting it set up right. Now Seth's going on and doing it without a calculator. They could have given easier numbers, right? They could have made this 350 maybe, $3.50, so it's more divisible by 5. So, wow, the answer is 390?
Yeah, I think so.
Yeah. Do you notice that Seth and I are both very slow in getting the actual answer? Because frankly, the actual answer doesn't matter. Of course it matters in the essay. Of course it matters. But what really matters right now, as far as we're concerned, is setting it up correctly.
This is a gridding question.
It's a gridding question, right?
Yeah.
So, but the SAT that's going to start for high school students in the United States in winter of 2024 is going to be only calculator, because it's going to be digital. Look it up. It's going to be on the computer, not on paper. And they're going to give you a calculator on the computer. So, chances are this would be a calculated question. But Seth did.
So I wrote a reminder of area on the left. Do a picture.
Right. The area is base times height. So, okay. Again, just right now, I would just consider this a calculated question. But Seth was very nice in doing it without a calculator.
And you can see why the area is equal to the product of the base times the height.
Right. But right. Yeah. So
again, this is I think this would be a 5th grade problem.
No, this is not a 5th grade question.
Yes, it is.
Maybe in your 5th grade, but not in. I don't think.
Yeah,
no.
6th grade problem.
Yeah, 6th grade problem. It's essentially a ratio. It's a ratio problem with a little bit of an area component to it. With a little bit of geometry component to it.
I guess before they taught kids ratios, they taught division. And then mathematicians realized, well, actually, division and ratio, they are a bit different, conceptually. Division is the inverse to multiplication.
Right.
And what's ratio?
Ratio is ratio. The most important part of ratio problem are the units. You're comparing one, you're having one ratio of something to something A to something B, and then they say, well, if the ratio of something 1 to something 1 to something 2, well, let's say thing 1 to channel Dr. Seuss, the ratio between thing 1 and thing 2 is given to you. So if you're given a certain different number of thing 1s, then how many thing 2s are you going to have if they're in the same proportion as the original thing 1 and thing 2? So ratio problems are critical. The key to ratio problems are the units. To set it up as a ratio problem, you go like this, right? Always put the units in dollars per square foot. Dollars per square foot. They told you that it was $3.25 for 500. You want to know the dollars. X square feet is the 200 times 300. And then you solve for X any way you want by mostly either cross-multiplying or multiplying by 200 times 300. Notice the units are the key. Classic ratio problem with a slight geometry component to it.
Yeah. Well, again, ratio is at least in big ratios. Big ratios is again, it's division. How many of the things and how many numerator quantities go into a denominator, which is how many do you have to multiply the numerator by to get the denominator? Numerator of denominator equals the ratio. Means that we're interested in R. Find the R such that denominator times the R equals the numerator.
What's interesting?
How many denominators go into the numerator?
Again, see how we're looking at the problem different ways. If you have the luxury of doing that, do that, because then you really it helps to completely understand what's going on.
You know what's interesting? The luxury of doing it is available when you study.
Yeah, right.
Not, you won't have the opportunity to take the test.
That's right. So when you study,
some kids get distracted on the test. Hey, they start thinking they find the question very interesting, and they forget about working on the other questions.
Well, I don't think that's going to happen too often when people take the SAT. You want to maybe sort of make one more observation about ratio problems. Many people who take math in high school will never use math, will never take another math class again in the rest of their life. So the question is, what is the most common math problem they will solve in their life that they will have to deal with? I'm going to present my opinion is that the ratio problem is going to be the problem that they're mostly going to be using in the rest of their life when they go shopping and they want to buy a certain number of pounds of sugar and it's $7 a pound. It seems to me like ratio problems is the problem that most people who don't use math or science in their career will use in their life. What do you think, sir?
I have no idea.
Okay, that's a good thing. But ratio, you will do ratio when you're shopping. You're doing ratio problems. When you're buying gas.
Well, nowadays most shopping is done by picking up packages.
Yeah, but what about making a party? Maybe you're making a party.
If you're making a party, yeah, you have to worry about, think about how much to get how much to get when you have an unusual number of people. Yeah, I think the issue with a party is for people who don't make parties very often. Then they have to think about how much stuff to get.
Yeah.
But if you're a party person, you make parties a lot, then you could know what to get from experience. But I say last time I didn't get enough potato chips.
No, but even if you do mock parties a lot, it's still a ratio problem. Because look, sometimes you'll have a small party. Sometimes you'll have a big party. You'll have to know that if you're going to have you know what you need to buy for a small party. You have to know, well, I should triple that for a big party. That's a ratio problem. So,
I'll boldly propose, most people, when they shop for a party, they don't think in terms of numbers at all.
Okay.
And then depending on how their attitude towards money, they might go in with the attitude that they won't spend more than a certain amount of money. Or if they have the attitude, at least for a party, that they just don't care. They just go through the store and say, "Oh, I'll take one of these. I'll take one of these. I'll take 3 of these." Just put them in the shopping cart.
Right. Yeah.
And pack them up.
Yeah. Okay, but anyway, I think ratio
people did fine. There were, the anthropologists tell us that many civilizations they studied, they did not even have concepts for counting numbers greater than 2.
Wow.
So they didn't think in terms of numbers.
Okay.
Because it was not part of their language. You were never taught You're never taught a word or a concept for three.
Interesting.
Yeah.
Interesting. Wow.
Oh yeah, yeah.
So they had.
However, an interesting thing about I read about some anthropological research is that they did study how people in a primitive culture knew their way around their environment, and they didn't think about things in terms of locations and distances. They thought of getting around in terms of landmarks that they remembered.
Interesting.
Yeah.
Interesting. And that's, in some ways, our primitive brains, when we drive, when we move around, that's sort of how we think when you go in, let's say you're in a high school or in a institutional building. You know where the things are relative to other things. Oh, this is near the stairway. Oh, this is near this office. This is near the gym. That's sort of the way, when you don't think about it, that's sort of the way we think about moving around.
Yeah.
Yeah. Right, we don't
You
think
don't think
that,
you don't think in terms of how many blocks a certain
right.
thing is away.
We don't think about how many.
Yeah. So math is underrated.
Okay. Well, whatever. Ratio.
I got my sign wrong. Math is overrated.
Oh, math is all right because many anthropologists.
You don't really need it. Yeah. What is SAT? Yeah.
No, actually, we shouldn't. People are very serious about it. We shouldn't joke about that. It's very serious.
Yeah.
But again, ratio problems are really common in life. So, and this is a ratio problem with a little bit of a geometry bend to it because you had to calculate the area of something. Okay, everyone, have a great day. We really are more than done with this. And congratulations to anyone who's actually listened to this thing for 16 minutes and 58 seconds. Okay, everyone, have a great day. Please like us, dislike us, give us comments on our YouTube videos, or email us at satmathquestion@gmail.com. And if you have math questions, SAT math questions you'd like us to go over, email us at the same email address, SAT math questions@gmail.com. Take care, everyone.